Hi. It's an honor to be here, and thank you, BUIDL and Crypto Seoul, for having us. I'm excited to talk about what we've been building and talking about what is about to come. So I want to start with why we do what we do. We believe in a vision. We believe in a future where thousands of interoperable blockchains connect together to form a scalable foundation for a new token economy. And we believe in that so much that we want to solve the problems, the hardest problems, to get us there. And we believe we have solved some of the core hardest problems, including things like the FT consensus, and as well as soon IBC, and also providing a framework for you to create your own blockchain so that you can connect to this ecosystem and help scale and extend this network that we'll soon be launching. In order to get there, we need a framework that makes it easy for everyone to create new blockchains. So I'm going to be talking about the Cosmos SDK, and I'm excited to talk about that. It's something that our team has been working on very passionately for the past year, and it's finally coming together. So let's talk about it. But first I want to talk about how we got here and what made us come up with the design decisions that we came up with. So let's talk about a little bit about the history of blockchain development. First, there was Bitcoin, which proved that you can have a decentralized BFT ledger powered by proof-of-work consensus. But when Bitcoin first came out, it was a large monolithic software stack. Of course, they were rightfully more interested in creating something that works than creating a large ecosystem, because they were the first to put it out there. And it created a wake. In the wake of Bitcoin, there were many other projects that were forked off of Bitcoin, like Litecoin and Namecoin, because they wanted to create their own community with their own reason for existing. But in order to create these alternative blockchains, these altcoins, they had to fork the Bitcoin code base. Unfortunately, the Bitcoin code base wasn't designed to make it easy to create new systems. It was also powered by proof of work, which is, in the context of our vision, thousands of interoperable blockchains, not the best solution for security in the long run. It was also limited in the scripting system, so the UTXO transaction model, as well as the scripting bytecode engine, was quite limited. And so then came Ethereum. With Ethereum, now developers could create new applications, smart contracts, and upload them to a single blockchain. But there were still limitations. I mean, don't get me wrong, Solidity and Ethereum are great, and sometimes they are the right solution depending on the use cases. However, Solidity requires programming in a new programming language that is still immature, in a sense. It doesn't quite have the tooling support that modern languages have that developers use, like Java or Go. We wanted to create a blockchain, a well-designed modular blockchain, starting from a framework in Go, because that's a language that we like to use, and it's got fantastic tooling. It's also quite performant. So in Ethereum, you can create a smart contract, upload it, but it also doesn't quite give you accessibility into the internals of the blockchain. So what if you want to create your own proof-of-stake blockchain, or a blockchain with its own staking token economics, with its own different kind of account cryptography and so on? It's not quite there yet. And while Plasma is still being rolled out, there are pros and cons to what you can do with Plasma. So we believe in a different network of blockchains that are connected by IBC and written in Golang. So that's what we've created. It's called the Cosmos SDK. We'll be launching the Cosmos Hub, which I'll talk about very soon. It's also built on the Cosmos SDK. And here are some of the design goals that we put out in developing the Cosmos SDK. It's meant to be secure, so it uses good design principles in its programming. So if you take a look at the code base, it's quite modular and well organized, and it makes it easy to create secure applications. It's modular, so it's intended to create an ecosystem of libraries or modules that come together so you can easily create your blockchain application. It's extensible, it's written in Golang, and it, of course, allows you to create a proof-of-stake blockchain. I'll talk a lot more about that. So, you know, like, when the Web 2.0 revolution was coming out, I mean, it was powered by frameworks like Ruby on Rails, and that's the kind of thing that we're targeting. With the Cosmos SDK, this developer-friendly framework, you can create your own blockchain, modify any component of it, but it's well designed and modular, so you can get all the features that you need implemented in there. And we're getting the feedback now through a lot of projects that are building on this that it's quite easy to create new systems, and that for the complex applications that they're creating, it's actually a better development experience than, say, programming in Solidity. Of course, it's open source. It's all available on GitHub, and like I said, it's all coming together now. Recently, we've been polishing the logic, and we've found a lot of bugs that we've fixed through invariance tests. It's really getting polished, and soon we'll have complete documentation so that you can go ahead and develop your own blockchain as well. It's on the bleeding edge now, so you can get started, but it's really getting there. Okay. And of course, I want to emphasize that the purpose of the Cosmos SDK is to create an ecosystem of libraries that we can all use. And I'll talk more about some of the modules that we have developed already, and some of the modules that other projects are developing on the Cosmos SDK. And the purpose is to allow anyone to create their own custom blockchain with the modules that they need, that they can pick and choose from to create either a sovereign, independent proof-of-stake blockchain, or one that is powered by a shared validator set, which I'll talk about in a bit. So let's talk about some of the modules that we've developed. These are the core modules that are baked into the Cosmos SDK. And so the Cosmos Hub uses these modules to power the Cosmos Hub. The first one is Tendermint. So let me tell you a bit about that, because this is how we got started. When Bitcoin first came out, you know, and around 2013, we saw that proof of work would eventually pose a problem in terms of not only environmental friendliness, but also in terms of security in the context of scaling to multiple, like thousands of blockchains. So we discovered a consensus algorithm, you know, and a family of algorithms that don't require proof of work at all. They were developed since the 60s, 70s, and so what we did is we took those learnings and adapted it into the blockchain environment and created a generic open source consensus engine that doesn't require proof of work and gives you fantastic security guarantees. And it's suitable not only for use in a private or consortium blockchain environment, but also in a public environment, in a proof-of-stake environment. And we tested this out actually in a testnet recently. It was called testnet 8001. Soon we'll be launching testnet 9002, but I think the thing to note here is that it proved that Tendermint can support over 100 validators that are all communicating with each other in a gossip environment to create a EFT ledger, committing blocks to finality every 5 seconds. So like, compare that to proof of work, which requires an hour to confirm a transaction. In a classical BFT engine like Tendermint, you can get blocks that are final every 5 seconds or so. And in different deployments, more local deployments with less validators, for example, it can be much faster. But what we care about mostly is starting with the public blockchain. So we've proven that you can have over 100 and soon hundreds of validators that are all working together to secure the blockchain. Now, you might think that 100 is not a lot, right? Because there are, of course, tens of thousands of miners or even more. But when you think about the number of mining pools and just how decentralized it is, as still with just, you know, like 20 mining pools representing 99% of the mining power, it's sufficiently decentralized. But actually, more importantly, if you want to create a fast finality blockchain in the context of it's called a partially synchronous network, meaning the internet where there's latency and so on. You can't do a whole lot better. There are theoretical limits, mathematical limits to how fast you can make secure public blockchain. And Tendermint reaches that limit. So that's what we try to provide is like the limit of what is possible through a state-of-the-art consensus engine. So when you use the Cosmos SDK, Tendermint is baked in, and you don't have to worry about consensus. Oh, it's also formally proven now, so we have a paper that describes the formal correctness of the Tendermint protocol. Now, of course, 100 validators is not a lot, right? It's not sufficient for us to feel that it is a secure public blockchain. In order to make it more accessible and more governed by stakeholders that are more than just the validators, we've developed a staking module, which is available in the Cosmos SDK, and which will launch with the Cosmos Hub, that allows for 10,000 delegators or more stakeholders to delegate their stake to any of the 100 validators. And unlike any of the other delegated proof-of-stake systems, we call this bonded proof-of-stake. When you delegate your stake to a validator, you are putting your skin in the game. So it's much more crypto-economically secure. It means that all of the stakeholders are going to be experts in determining, what is the right thing to do. The stakeholders are meant to be active participants in determining how the blockchain evolves and what to do in the case of various kinds of failures. So this is a novel and innovative proof-of-stake staking protocol, staking module that's available to you as a library if you develop on the Cosmos SDK. And I want to emphasize that the original vision that I mentioned of creating, thousands of interoperable blockchains that are connected to each other to create a scalable token economy, it doesn't require Tendermint, right? It can also work with other classical BFT engines. It can also work with other frameworks, but this is just a set of tools that we recommend today. In the future, because we've created modular interfaces and APIs that work together, we'll see alternatives and different consensus engines even, and it'll all be part of a network of blockchains that are connected through inter-blockchain communication, or what we call IBC. But this is just what we have today. And so if you want to develop a proof-of-stake network and connect it to an extensible, growing network, then the Cosmos SDK is probably what you want. Let's talk about another module, governance. So if you've been reading the news about Bitcoin Cash and how it's splitting, and even what happened with way back with the ETH DAO hack and how Ethereum split into Ethereum and Ethereum Classic, one thing that we noticed a public blockchain needs is a way for the stakeholders to come to agreement about what to do about various situations. Now there are like hundreds or thousands, uncountably many situations that can arise during the execution of a public blockchain, and instead of just forking it, which is it's difficult to coordinate. It's expensive for the community to have to deal with all these forks. It would be better if we can have a governance system where there's a strict procedure on how to come to agreement about what to do. And so the governance module is one that allows the stakeholders of the Cosmos Hub to come to agreement about how to upgrade the blockchain and what to do in the case of various kinds of failures. I think it's a necessary component of a public blockchain. So this module allows for text proposals, so you can create any kind of text proposal, a generic one, and there's a voting process. It can also be used for arbitrary parameter changes. The Cosmos Hub is going to have a lot of parameters that can be tweaked through governance. Of course, it can also be used for upgrading the chain to add new features. Maybe the most interesting thing about this is that it's sort of a limited liquid democracy, because the validators need to vote. They are intended to be actors that are on call and are aware about the situation and are actively participating in making decisions on a day-to-day basis, on an hourly basis even. But the delegators who delegate to them, they at first inherit the vote of the validator that they delegated to, but then they can also override and make their own votes. So it's a kind of liquid democracy that is enabled through this module. And of course, the rewards and fees. So every blockchain needs incentives, and the Cosmos Hub allows you to not only accept fees in the Atom token, but other whitelisted tokens as well. So the idea is that through governance, it can approve of additional tokens that are whitelisted, so that you can pay your transaction in any kind of token. And soon we'll be able to, maybe we'll add a feature to automatically exchange between them, perhaps connected through a DEX. But it's a powerful thing to be able to say, many kinds of tokens can be accepted as a fee token. It allows for more inclusive user base. So it's a multi-asset system. It's a flexible reward and fee system that is all available to you through modules. Now, we've been developing the Cosmos SDK for a year now, and currently what we're doing is we're polishing it, we're making it steady, secure, so that we can launch it with governance. And as soon as we are done with that, then we will implement the IBC spec that we've been working on. So we have a specification for how to have secure inter-blockchain communication, and that will be also available to you as a module. And so when that's available, it'll be available on the Cosmos Hub after a governance proposal. And the nice thing is, if you build your application on the SDK now, it'll be available to you just as an import and integrate with all the other modules that we provided. So IBC is a lot like TCP/IP. The idea is that today, two blockchains like Bitcoin and Ethereum aren't aware of each other. They can't communicate with each other except indirectly. But by building the consensus system from classical BFT consensus algorithms, it turns out it's possible to have two blockchains that can securely, directly communicate with each other. And that's because technically it's because the light client proof about the state of the blockchain is much cheaper and it's faster to create than a proof of work. And so you can actually submit the proof of the other blockchain state as a transaction on a blockchain, and that's the basis for IBC. The Cosmos Hub is going to use IBC for token transfers, so two-way pegging of tokens between all the blockchains that connect on the Cosmos network. But the idea is that this library will be available for all kinds of purposes, not just token transfers, but like TCP/IP is a generic communication protocol between two computers, IBC will implement it so that you can use it for all kinds of purposes, not just token transfers, but perhaps cross-chain smart contract calls, state reading of the other blockchain. There's a lot of things you can build using this module and these techniques that we're developing. So the idea is that anyone can create their own blockchain and they can extend the Cosmos ecosystem by launching their own sovereign chain and connecting to the Cosmos Hub. I want to show you some of the projects that are building on this now. So of course the Cosmos Hub itself is built on the Cosmos SDK. We'll launch with all the core modules that we're developing, plus after we launch, we'll enable IBC, which will allow the Cosmos Hub to communicate with other Tendermint or Cosmos SDK built blockchains. But we'll also connect to proof of work chains like Ethereum through the additional modules like Peggy. So it is possible to have two-way pegging between a proof of work blockchain like Ethereum and the Cosmos Hub. It just requires a little bit more work in a different module. Ethermint is something we're developing now. It is also built on the Cosmos SDK, and the idea is that with the EVM module, you can run smart contracts in a 100% compatible way, or 99.99%. And so Ethereum currently has a scaling problem. Plasma allows for some kind of scaling in that the shards or the child chains can run, there are all kinds of applications, but predominantly UTXO-based applications. With Plasma, it's difficult to have child chains that are running arbitrary smart contracts, like EVM contracts. What you can do with Ethermint is, in the Cosmos SDK and the shared security module, is you can have many Ethermint chains that are run by the same validator set. So, kind of going back to what I was saying earlier, with proof of work, it's difficult to scale to many blockchains that are all each secure because you're splitting the security of proof of work among many blockchains. But with proof of stake and Tendermint, you can have the same validator set that is responsible for validating on many chains. And if you do, if one of the validators does something wrong on one chain, you can imagine the policy is that it gets punished or slashed on a master chain, and then all of the, we call it slave chains or replica chains, will copy the modification, the newly modified validator set according to how the validator set is being updated on the master chain. And so this allows for scalable blockchain ecosystem because you can have many blockchains that are secured by a common validator set without sacrificing security as you would have to do in proof of work. So now you can imagine many Ethermint chains allowing for lots of smart contracts to run across many parallel blockchains, all coordinated by the Cosmos Hub. The Iris network is another blockchain being developed in the Cosmos SDK. You can think of it as a microservices directory. So it's a directory for all kinds of services to be offered, so that you can, for example, store. You can imagine a storage service which integrates offline computation, offline storage, and services, all coordinated on a blockchain. You can also think of Iris as a regional hub for Greater Asia. And the idea is that the Iris hub will connect to the Cosmos hub. And so what we see is, it's a network that's not just centered and coordinated and owned by the Cosmos hub, but we're trying to create a network of hubs as well, because that's what we believe is needed for a truly scalable token ecosystem. There's also Lino. It's distributed content delivery on the blockchain, so you can think of it as decentralized YouTube. Kava, it's a blockchain that's being developed in the SDK, allows for micropayments and payment channels and interledger protocols. So think of moving your tokens from the Cosmos Hub over to the Kava blockchain, or Kava zone, and then you can use the services provided by Kava for making payments. Fourth State is another experimental blockchain for developing Plasma on the SDK as well. So these are some of the blockchains that are being developed now, but every week we learn about a new blockchain that's building on the Cosmos SDK, and we're getting very good feedback. So please take a look at it. There's a lot of things that's going to be built, and we'll be building an ecosystem next year, and it's going to be very exciting. Now, the purpose of this, of course, is to create, I want to reemphasize the vision, thousands of interoperable blockchains that are connected to create a scalable token economy. So here's the Cosmos Hub, which we're going to launch very soon, and we'd love to have you join us. Please go to this website, cosmos.network/BUIDL 2018 to learn more, or just scan the QR code, and we'll send you updates as we launch the testnet, 9002, and launch the Game of Stakes incentivized testnet. It's going to be very exciting. Thank you very much. Do we have time for a Q&A? Maybe one or two questions?
I think one or two questions will be fine.
Okay. Anyone have a question?
혹시 질문 있으시면은 손을 들어 표시해 주시면 마이크를 가지고 드리겠습니다.
Yes.
So the modules were really interesting, and could you maybe elaborate more about microservice module?
Sure. The idea is to create service-oriented architecture and to provide a directory of various services that are coordinated through the blockchain. So you'll be able to discover new services such as storage services or computation services. And those services don't have to live on the chain. The idea is that it's bridging the gap between off-chain services coordinated on the chain. So there's There's one place that you can go to pay, make payments, to create accountably transparent, auditable requests, and also make payments. But have the idea is that there's a transparent central place on a blockchain where all the microservices are available. Talk to the Iris network. They are here today, so come to me and then we'll connect you to them. Of course. Maybe one more question.
Well, would this be your last question?
Okay.
Hi. So thanks for the presentation. So my understanding is that different chains have different characteristics in terms of how they reach consensus and how long it takes for them to reach consensus and things like that. So have you looked at any fundamental limitations or constraints that what these interchain protocol can provide versus what are the things that can be done or what are the things that cannot be done?
Yeah, I think that's a good question. It's a pretty deep one. So I think one of the most interesting things about that we are thinking of now and will need to be solved soon, we have some grasp of it. It's the question of what to do in the case of blockchain failure. So if you have the Cosmos Hub, for example, and many other blockchains, there are various failure scenarios that can arise because maybe one connected sidechain forked or halted, but even the Cosmos Hub itself can fork. So there are all these failure scenarios. There's a basic way to recover from that situation, which involves over a period of synchronous time, collecting votes, and then seeing which fork has the most amount of support behind it. I don't have time to go into some of the details now, but that's the most interesting area of research, apparently.
All right.
Thank you very much.
네, 다시 한번